Imagine an organ that works for you nonstop, yet you can't even remember the last time you thought about it. It doesn't beat like the heart, so you don't feel its rhythm. It doesn't breathe like the lungs, so you can't hear it at work. It doesn't hurt as quickly as the stomach, so it rarely protests. And yet, it takes on more tasks than any other organ in your body. That organ is the liver, the most underrated hero of the biological stage, quietly saving you day after day from the consequences of your own life. In literature about the human body, words like command center, engine, storage unit, and purifier often appear. But if any organ deserves all of these titles at once, it's the liver. Silent, resilient, incredibly hardworking. The liver exists at the intersection of two worlds: what you eat and what you do, what you drink, and what you experience. It is a chemist, a guardian, an energy producer, and a toxicology lab, constantly neutralizing the effects of your mistakes, both small and large. The liver doesn't hide deep inside. It sits just under your ribs, on the right side, close enough to the surface that a doctor can feel its edge with their hand. Yet, despite this accessibility, for most people it remains completely invisible. It's the largest internal organ in the human body. Can you picture it? Try. Enormous, smooth, glistening, the color of deep red wine. Its shape resembles a flattened, irregular crescent, so large it occupies much of the right upper quadrant and part of the central upper abdomen. If you were to hold it in your hands, which of course you wouldn't want to, you'd feel its firmness with a hint of softness, something between muscle and a very dense gel. In an adult body, the liver weighs about 1 to 2 kilograms. That's not a mistake. You carry an organ heavier than your brain, larger than both lungs combined in working volume, and more richly supplied with blood than any other organ except the heart. Despite its size, its work is incredibly subtle. Not a single vibration of its activity reaches the surface of the body. You don't feel the blood flowing through it, up to 1.5 liters per minute. You don't hear the chemical reactions inside, even though thousands occur every second. If you could look inside, you'd see a dense network of ducts, veins, arteries, and microscopic cells, hepatocytes, working like a massive factory in total darkness, without noise, but in absolute, uninterrupted motion. The liver is large, heavy, and powerful, yet simultaneously exceptionally delicate. From the outside, the liver looks calm and uniform, but appearances are deceiving. Beneath its smooth surface lies a precise division into parts, working like separate departments in the same gigantic factory. The first, most visible division is into lobes. While textbooks usually mention only right and left, reality is far more fascinating. The right lobe is massive, so large it could almost be considered a separate organ. It occupies most of the space under the right ribs and accounts for a significant portion of the liver's metabolic machinery. When a surgeon opens the abdominal cavity, this lobe is the first thing they see: massive, wide, dominant. The left lobe, though smaller, is more analytical. It participates more often in precise procedures, resections, and transplants because its blood vessels and bile ducts are easier to navigate. But that's not all. Anatomists also distinguish two smaller yet highly important lobes: the caudate and quadrate lobes. The caudate lobe is small, tucked away, but remarkable. It has its own blood supply and can function almost independently. In some diseases, when one lobe is compromised, it can take over tasks and grow compensatorily, like a reserve module suddenly handling the load. The quadrate lobe, on the other hand, lies closer to the gallbladder and bile ducts, a strategic location, as most logistics of bile production and transport pass through here. Clinically, this region is sensitive, easily affected by inflammation or pressure, which can impact the patency of the ducts. Externally, the liver is encased in a thin, elastic Glisson's capsule. It's like a delicate membrane that protects the organ's structure while reacting to stretching. It's this capsule, not the liver tissue itself, that can hurt when the organ enlarges due to inflammation or fatty buildup. The liver's external architecture, its lobes, grooves, and fissures, is just the surface. Even at this level, you can see it's no ordinary organ with a simple design. It's a multi-lobed, multifunctional machine, where each element has its role and its own vascular pathway. And the deeper you look, the more astonishingly complex this organ becomes. Most abdominal organs lie freely. The stomach, intestines, and spleen hang from the mesentery and shift slightly with each breath. The liver is different, anchored to the diaphragm and abdominal wall by ligaments, almost stuck under the right rib cage. It's more stable, like a solid block designed not to move. In the abdominal cavity, you may find organs larger in volume, like intestines, but none combine mass and structural density like the liver. It's the only organ weighing over a kilogram while maintaining a compact, uniform structure. No empty spaces, no internal lumen like the intestines or stomach. The liver is also the only abdominal organ receiving blood from two independent sources: the artery and the vein, supplying blood from the entire digestive system. Neither the stomach, pancreas, nor intestines have this dual supply, making the liver a central hub of blood flow. Most abdominal organs have smooth muscle interiors, intestines, mucosal folds, stomach, or a parenchyma with a single duct, pancreas. The liver has a unique lobular structure. Millions of microscopic hexagonal units not found anywhere else in the body. Most abdominal organs have a direct lumen through which food passes. The liver, paradoxically, never touches food. It has no lumen, no gastric contents, no direct contact with the intestines. Its entire relationship with the digestive system happens at a distance, through vessels and bile ducts. No large abdominal organ is as silent as the liver. The intestines hurt, the stomach hurts, the spleen hurts. The liver, its tissue doesn't feel pain. Only its capsule can hurt when the organ enlarges. Hepatocytes are the cells that make up the liver. But calling them cells is like calling a nuclear reactor a heater. They are the smallest units of one of the most overworked and powerful biochemical factories in the body. If you could magnify a hepatocyte, you'd see something resembling a tiny laboratory with its own storage, assembly lines, detox system, power plant, dispatch center, and shipping line, all in a single cell. Every liver contains billions of hepatocytes. They are arranged in regular geometric structures called lobules, and their arrangement is deliberate. They look like perfectly organized workstations in a massive factory. Each hepatocyte has access to a vascular network on one side and a system of bile canaliculi on the other, allowing it to work in two directions simultaneously, processing blood while producing bile. So what makes hepatocytes so incredibly crucial? First, they are astonishingly versatile. Most organ cells have one, maybe two specialized functions. Hepatocytes have dozens. They produce blood proteins, detoxify toxins, break down hormones, store glycogen, transform fats and amino acids. One cell performs tasks that would require entire tissue teams elsewhere. Second, they are true cleaners of the body. Each hepatocyte contains internal enzyme systems, especially cytochrome P450, that act like chemical filters. They can break down alcohol, medications, pesticides, preservatives, dyes, even substances the body has never encountered before. This is not passive filtration like in the kidneys. Hepatocytes actively modify and neutralize chemical compounds. Third, they have an extraordinary ability to regenerate. Hepatocytes can divide even when many other cells in the body have long lost that capacity. And when part of the liver is removed, it's these hepatocytes that spring into action, multiplying intensively and rebuilding the organ's structure. There is no other type of cell in the entire digestive system quite like them. Fourth, they are among the most blood-rich cells in the body. Every hepatocyte is bathed in blood almost constantly, connected to one of the most extensive vascular systems in the body. That's why any changes in circulation, inflammation, or toxins immediately affect their performance. Fifth, they bridge two worlds at once. On one hand, they receive blood from the intestines, full of nutrients but also potentially harmful substances. On the other, they produce bile, a fluid that carries away what the body doesn't need. They are the only cells in the body that are simultaneously part of both the circulatory system and the biliary system. Sixth, they work without pause, without rest phases. At night, your muscles recover, your stomach slows down, your brain switches into a cleaning mode. Hepatocytes work exactly the same day and night, like a power plant that can never turn off, because the rest of the body depends on its 24/7 activity. That's why when hepatocytes begin to malfunction, there is no organ that doesn't notice it. Every disruption in their function affects metabolism, energy, immunity, hormones, blood clotting, digestion, and even the condition of your skin. A hepatocyte is more than a cell. It's a control center for the entire body. If we could shrink down to microscopic size and step inside the liver, we'd enter a world as complex as a bustling city. Every cubic centimeter of the liver contains hundreds of thousands of tiny units called liver lobules. It's like a factory within a factory, where each section has a precisely planned role and carefully mapped pathways for raw materials and finished products. Each lobule is a hexagonal structure, like a perfect honeycomb. At its center sits a central vein, and at the corners are the hepatic triads, the entry point for two sources of blood and the exit for bile. In this tiny world, blood from the portal vein and hepatic artery mixes in sinusoidal channels, flowing around the hepatocytes like rivers weaving around houses in a medieval town. Hepatocytes extend their arms toward these channels, absorbing nutrients while simultaneously neutralizing toxins, while tiny bile canaliculi carry produced bile in the opposite direction, out toward the edges of the lobule. This remarkable design allows each hepatocyte to operate in two directions at once, taking in and processing raw materials while sending waste products out as bile. Lobules are not uniform. Within each hexagonal unit, there are zones with differing access to oxygen and nutrients. Hepatocytes nearest the triads receive the highest oxygen supply and are responsible for intensive glucose production and fat metabolism, while cells near the central vein work under lower oxygen conditions, focusing mainly on detoxification and processing alcohol and medications. This is where most liver damage begins, because these hepatocytes operate at the edge of endurance. Yet the entire structure is designed so that even if some lobules are partially damaged, neighboring units can compensate, and the liver as a whole continues to function. This is why the organ can regenerate in a way unmatched elsewhere in the human body. Within the lobules, you can see the genius of evolution, the microarchitecture that combines stability and flexibility, structure and function, continuous work and repair capacity. Thanks to this, the liver can operate non-stop, cleansing blood, processing nutrients, and secreting bile day and night throughout a person's lifetime. From the outside, the liver looks like a smooth, uniform mass. Inside, however, it pulses with activity, exchange, and precise organization that determines the health of the entire body. Liver lobules are not just structural units. They are microscopic cities of life, where every cell matters and chaos is absolutely absent. Blood reaches the liver through two parallel pathways, joining only in the microscopic spaces of the lobules. The first is the portal vein, bringing blood from the entire digestive tract, carrying freshly absorbed nutrients along with any foreign substances, toxins, and metabolites. The second is the hepatic artery, supplying oxygen-rich blood, essential for the hepatocytes, which cannot afford a moment of pause in their mission. These two sources mix masterfully, giving hepatocytes the perfect balance of energy and raw materials for simultaneous protein production, detoxification, storage, and bile formation. Once blood enters the lobules, it flows through a network of sinusoids, microscopic vascular channels with a special porous structure. Sinusoids are where the magic happens. Hepatocytes capture nutrients from the blood, store glycogen, break down toxins, and at the same time allow blood to continue flowing toward the central veins, which drain cleansed blood into the hepatic veins. Thanks to this structure, not a single molecule escapes the hepatocyte's attention, and every micrometer of vascular space is used to maximum efficiency. In this system, blood flows slowly, allowing for thorough exchange, yet it never stops, as if every street and every bridge were constantly monitored, and every transporter knew exactly where to go. The combination of portal vein and hepatic artery, along with the microscopic sinusoidal network, ensures the liver functions like a continuous chemical factory, keeping the whole body alive and healthy. This precise vascular architecture makes the liver a unique organ, the only one in the body that, thanks to this dual supply and system of microscopic streets, can function simultaneously as a filter, storage facility, factory, and chemical lab. Any change in blood flow, narrowing, or vascular damage immediately affects the function of an entire lobule, and thus the whole organ and body. Now, imagine the liver not only as a life-sustaining factory and detox center, but also as a giant kitchen, producing a crucial digestive juice, bile. For many organs, bile seems abstract, but in reality, it is a true liquid worker, allowing the body to absorb fats, break down fat-soluble vitamins, and remove metabolic waste. Bile is produced right within the hepatocytes. Each cell creates microscopic portions, which are then directed into bile canaliculi, tiny ducts weaving through the lobule like narrow city streets. Here, coordination is remarkable. Bile flows in the opposite direction of blood. Blood from the portal vein and hepatic artery moves from the edges of the lobule toward the center, while bile moves from the center outward toward the triads, where the canaliculi join into larger ducts that carry bile out of the liver. It's like reverse traffic in a city. Raw materials flow in while finished products flow out. Once bile leaves the liver, it enters the gallbladder, which acts as a storage and concentration hub. The gallbladder doesn't just store bile, it thickens it, removing some water so that when it is released into the small intestine, it is more concentrated and effective at emulsifying fats. At this stage, the pancreas joins the process, supplying digestive enzymes that work in tandem with bile. Together, they form a dynamic duo. Bile breaks down fats, enzymes digest them further, and the small intestine can efficiently absorb nutrients. Each liver lobule, with its network of hepatocytes and bile canaliculi, operates like a microscopic production station. Each tiny portion of bile from a hepatocyte is collected by the canaliculi and sent toward larger ducts. Every second, hundreds of thousands of these microscopic deliveries happen simultaneously, creating a continuous river of ready-to-use fluid that flows through the gallbladder and then into the duodenum, beginning its crucial role in digestion. Thanks to this precise architecture and the harmonious cooperation of the liver, gallbladder, and pancreas, our bodies can make use of fats and vitamins that would otherwise go unabsorbed. Any disruption in bile flow, any blockage in the ducts, or dysfunction of hepatocytes immediately impacts digestion, metabolism, and overall health. That's why bile is such a small yet incredibly powerful hero in the world of the liver, barely visible at first glance, but absolutely essential for the body to function. Imagine the liver as a massive, pulsating factory, each section specialized in processing a different type of raw material. Every bite of food, every molecule absorbed by your intestines, arrives at the liver through the portal vein, like raw materials delivered by trucks to an industrial hub. In this metropolis of life, carbohydrates, proteins, and fats each have their designated production lines and processing stations. Carbohydrates, the body's main source of energy, are processed quickly. Glucose enters hepatocytes, where it can be used immediately as fuel, stored as glycogen for later, or converted into fat when energy reserves are abundant. It's like a dynamic energy warehouse, responding to the needs of the entire body, releasing glucose into the bloodstream when energy is needed, or holding it back when supplies are sufficient. Proteins, arriving in the liver as amino acids, undergo equally complex processing. Hepatocytes synthesize essential plasma proteins, such as albumin and clotting factors, while excess nitrogen from amino acids is converted into urea and safely excreted. It's as if the liver runs its own chemical laboratory. Some raw materials are turned into components vital for the body, while others are neutralized and safely dispatched. Fats, meanwhile, arrive at the liver both as an energy source and as building blocks for essential structures. Hepatocytes convert them into lipoproteins, store some as triglycerides, and release the rest into the bloodstream for use by muscles or other tissues. In this way, the liver not only regulates energy flow, but also maintains the body's lipid balance. The entire process of nutrient metabolism in the liver operates in perfect harmony with the body's rhythm. Each liver lobule contributes to this work, with hepatocytes acting like specialized workers in a vast, continuously running enterprise, ensuring the body receives precisely the right amount of energy and nutrients at every moment. Thanks to this, the liver becomes the body's energy command center, a chemical refinery, and a safety warehouse, regulating, processing, and delivering nutrients in the most efficient way possible. Imagine the liver as the body's guardian, standing at the border between what comes from outside and what is produced internally. Every molecule entering the bloodstream, food, drink, medication, or even tiny amounts of environmental toxins, arrives at the liver like raw materials at a quality control center. Hepatocytes act as specialized chemists. They capture, break down, neutralize, and process every substance, ensuring it can either be safely excreted or repurposed by the body. Detoxification happens in two stages. First, the liver converts foreign compounds or metabolic byproducts into more reactive forms, and then transforms them into water-soluble substances that can be eliminated in urine or bile. This is how the body handles medications, alcohol, or chemicals that, without this safety factory, would accumulate in tissues and cause damage. Alcohol detoxification is one of the most well-known examples. Every molecule of ethanol is captured by hepatocytes and subjected to a sequence of chemical reactions that gradually neutralize its toxic effects. Enzymes processing medications, from acetaminophen to antibiotics, work similarly. The liver converts them into forms that are easily excreted, minimizing the risk of harmful buildup. This relentless process is so efficient that most people are unaware of how intensively their liver works. It's like an invisible front line, protecting the body 24/7. But if hepatocytes become overwhelmed by excess alcohol, drugs, or toxins, the detoxification process slows and harmful substances begin accumulating, leading to inflammation, fatty liver, or cirrhosis. The liver constantly balances between accepting raw materials and protecting the body. Every lobule, every sinusoidal street, and every hepatocyte works together in this microscopic system that determines overall health. Thanks to the liver, the body can tolerate a world full of chemicals, food, and medications that would otherwise be dangerously toxic. The liver is also a laboratory producing the body's most vital blood proteins, unseen yet absolutely crucial for life. Every day, hepatocytes synthesize vast quantities of these proteins, from albumins, which maintain fluid balance, to complex clotting factors, which decide whether a small wound becomes a catastrophe or is quickly sealed. The liver acts as an invisible security guard, with blood proteins as its tools to maintain order. Albumins, the most abundant plasma proteins, function like invisible transport warehouses. They bind hormones, vitamins, and medications, allowing them to circulate safely through the body, while maintaining stable concentrations in the blood. They keep blood osmotic pressure steady, preventing fluid from leaking into tissues and causing swelling. Clotting factors, on the other hand, are complex enzymatic cascades that trigger reactions at the right moment, forming clots and sealing damaged vessels. Without the liver producing them, even a minor injury could become life-threatening. Hepatocytes are thus invisible producers of protection, creating proteins that act as a safety net for the entire body. Other proteins, lipid transporters and acute phase proteins during inflammation, also originate in the liver. They alert the body to threats and mobilize immune responses. Each protein is produced in precisely calibrated amounts according to the body's needs. The liver acts like a master conductor, ensuring every note is played at exactly the right moment, so the symphony of life continues uninterrupted. Protein synthesis is therefore one of the liver's most important yet least appreciated functions. It works silently every day, and we only notice its importance when it begins to fail. Hepatocytes never rest. Thanks to them, the body maintains balance, the ability to regenerate, and protection. Every drop of circulating blood bears witness to their constant, precise work. Picture the liver as a giant warehouse of life-sustaining energy and essential substances, operating invisibly in the background, yet crucial for survival. Every lobule, every hepatocyte is like a chest of valuable resources, ready to deliver precisely what the body needs at any given moment. In this microscopic world, there is no chaos. Everything is organized and planned, from glycogen to vitamins and minerals that support cellular life. Glycogen is the first line of energy storage. In the liver, it's stored as tiny granules, ready at any moment to be broken down into glucose and released into the bloodstream when the body suddenly needs fuel. During physical exertion, stress, or between meals, it's like an invisible reserve tank, ensuring the body never feels an energy deficit. Hepatocytes constantly balance storing and releasing glucose, deciding when the body needs immediate energy and when it can be saved for later. Alongside glycogen, the liver stores vitamins A, D, E, and K, fat-soluble treasures supporting vision, immunity, blood clotting, and more. Hepatocytes act as vigilant guardians, releasing these vitamins in precise amounts depending on the body's needs. Every molecule has a specific place and function. Loss of control could lead to deficiencies or toxic buildup. Equally important are minerals: iron, copper, zinc, and others. Iron, stored as ferritin, is needed for hemoglobin production, oxygen transport, and many enzymatic reactions. The liver regulates its levels, protecting the body from both deficiency and excess, which could damage tissues. The same goes for other minerals. Each has its role, and the liver decides when and how much to release into the bloodstream. The liver is an organ that not only works non-stop throughout life, but also has the remarkable ability to rebuild itself even after serious damage, as if it had its own superpower. It is one of the few organs in the human body that can tolerate mass loss. Sections can be surgically removed, and the remaining tissue regenerates to nearly full size. This process isn't magical. It's a perfectly orchestrated biological plan. Hepatocytes divide, activated by hormonal signals and growth factors, while other liver cells reorganize, forming new lobules and restoring blood flow and bile ducts. Liver regeneration is precise and depends on multiple factors. Under ideal conditions, hepatocytes are ready to divide almost immediately after injury. Signaling proteins, hormones, and cytokines are key. They inform hepatocytes of the need for repair. The liver also responds to reduced functional mass. Increased blood flow through remaining tissue mechanically stimulates cell division. It's like a city that loses part of its districts. The remaining districts immediately increase production and rebuild roads to restore full functionality. However, regeneration is not limitless. Excess toxins, Chronic inflammation, heavy alcohol use, or certain medications can impair repair. Hepatocytes become overloaded, growth signals are blocked, and instead of healthy lobules, fibrous tissue forms, the beginning of cirrhosis. Lifestyle, diet, sleep, and physical activity have a real impact on how effectively the liver can rebuild after injury. What supports regeneration? A diet rich in protein, antioxidants, and micronutrients, avoiding chronic alcohol and toxins, and managing chronic diseases. All of this allows hepatocytes to work efficiently and divide at the proper pace. In contrast, liver overload, nutrient deficiencies, or chronic stress significantly limit its regenerative capacity. What sets the liver apart is not just its regenerative ability, but the coordination of the entire process. Every lobule, every hepatocyte knows when to divide, when to produce proteins, enzymes, or bile, and when to focus energy on rebuilding structure. This precise orchestration allows the liver to respond almost instantly, so the body doesn't feel a loss of function, even if a significant portion of tissue has been removed or damaged. The liver does have its limits. When it is burdened over years by an unhealthy lifestyle, chronic alcohol use, excessive medication, or a diet full of processed foods, its regenerative capacity slowly begins to wane. What starts invisibly can gradually become a serious threat to health. One of the most common problems is fatty liver disease. Excess fat in hepatocytes causes them to enlarge and impairs metabolic function. Often, this condition is silent. Most people feel no symptoms for years. Yet over time, the liver becomes less efficient at detoxifying, metabolizing drugs, and regulating glucose. If the process continues unchecked, it can progress to steatohepatitis, damaging hepatocytes and activating stellate cells, eventually forming fibrous tissue. Another major threat is cirrhosis and chronic hepatitis, which can result from viral infections, HBV, HCV, toxins, or autoimmune processes. In cirrhosis, healthy lobules are replaced with fibrous tissue, disrupting the liver's architecture, impairing blood flow, and reducing production of essential proteins. Even the liver's regenerative superpower is not enough to fully recover. The process becomes irreversible. Risk factors significantly accelerate liver degeneration. Obesity, type 2 diabetes, diets high in sugar and trans fats, chronic alcohol consumption, and overuse of certain medications or supplements. All these elements act cumulatively. Combined with genetic predispositions, they dramatically increase the risk of liver disease. One of the liver's most intriguing paradoxes is that it doesn't hurt like other organs. It lacks pain receptors for standard stimuli such as pressure or stretching under normal conditions. That's why fatty changes, inflammation, or fibrosis can develop silently for years, without warning signs. Pain usually appears only when the liver becomes enlarged or presses against its fibrous capsule, a signal that disease has already reached an advanced stage. Another fascinating fact is that the liver can store large volumes of blood, up to half a liter in emergencies. It acts as a flexible blood reservoir, protecting the body against sudden volume loss during injury or shock. This is one of its hidden superpowers, unknown to most people. The liver is also the only organ capable of surviving partial resection and nearly complete regeneration, even if half of its mass is removed. Few organs in the human body have this ability, making the liver a true master of adaptation and repair. Another remarkable feature: the liver dynamically produces proteins, lipids, and glycogen, responding to every meal and metabolic change. It acts like an invisible, constantly operating warehouse, converting nutrients into energy, building blocks, and enzymes, as needed by the body in real time. We mustn't forget that the liver is also a central hub for drug and hormone metabolism. Virtually every pharmaceutical entering the bloodstream passes through the liver. It is broken down, transformed, or activated there. Thanks to this organ, many medications are safe and effective. while toxins from food or the environment are neutralized. Ultimately, the liver is the invisible hero of everyday life. Its work goes unseen. Pain is rarely felt. Yet without it, the body couldn't survive a single day. It is a hidden superorgan, combining metabolism, detoxification, energy storage, and protein production into one seamlessly operating system.